with glacial cycles where it takes quite a long time to fall into a glaciation, but when you come to the end of a glaciation, the world comes out of it quite quickly, and it usually comes out of a glaciation in the space of 1,000 or 2,000 years. So the idea is, and during that period when they're coming out of a glaciation, the ice thins enormously rapidly, and then it thickens very slowly. So the idea is, if you have some crustal magma chambers and they're being loaded by thick ice during a glacial, the ice helps to keep the magma in the chamber just because of the pressure effects. Then if you remove that ice or make it significantly thinner, you release a lot of pressure, and just like taking a cork out of a Coke bottle, for example, a lemonade bottle there, the magma chamber starts letting off volatiles and it will erupt. So the idea is that during the transition from a glacial to an interglacial, there should be far greater numbers of eruptions. Eruptions will also occur within glacial periods, but a majority will occur towards the end of a glacial. But there are enough within the glacial to make it interesting there too. So I suppose you can anticipate that there are several active volcanoes in Antarctica, and I suppose potentially if the ice in Antarctica is thinning very fast, which is not thinning that fast just now, then you might trigger more eruptions there. If you trigger many eruptions, then technically you could perhaps destabilize the West Antarctic ice sheet, but that is by no means proven. Like most things scientific, what seems like a one-to-one obvious correlation, there are often other checks and balances in the system which work against that. The system is often, in a sense, self-regulating. So I would like to say that yes, if the West Antarctic ice sheet began to get much thinner, we'd have a lot of eruptions. We may do. In that particular case, I'm slightly skeptical. Some people have suggested that yes, if you thin the ice, you'll get more eruptions there. That will be pumping more heat into it, will thin even more ice, etc., and become a runaway system. But in terms of the pressure fluctuation, it'd be quite limited, because when you remove, because the West Antarctic ice sheet is grounded, but grounded below sea level, as you melt the ice and it rises off the sea floor, water rushes in. And so what pressure has been lost by thinning the ice is replaced by the water that replaces the ice. So in fact, the pressure change is not going to be extremely large. And I don't think we will see a runaway effect of lots of eruptions helping to destabilize the ice sheet. So it's an interesting problem which no one has actually sat down and worked through logically, although I'm quite sure people could do that now if they wished.
Interesting, a lot of opening. We have Roberto asking, well, he said that he really liked your presentation, and he went to two different volcanoes, the Vesuve and the Etna, and he would like to start to participate in a group of, to study that kind of issue as volcano in Antarctica. So he was wondering if you could suggest where to start to do that kind of study in the future.
Ooh, that's a hard one to know how to answer. Etna and Vesuvius are both interesting volcanoes which I have visited but never worked on, unfortunately. There are observatories attached to both of them, and it must be relatively straightforward, I think, to get in touch with people there to ask about the kind of work they do. The way I got, and that way that will, if you can accompany these people on some of their fieldwork, perhaps as a guest, they can show you what they're doing, what they're working on, and that will give some experience in the rocks themselves. In terms of my own career, I was in the right place at the right time. When I was an undergraduate, I was always more interested in volcanic rocks. When I got my first job at the British Antarctic Survey, they gave me a piece of the Antarctic Peninsula to work in, which was largely volcanic rocks. And when I left BAS for 5 years, when I came back again, they asked me to form a volcanic section. So I was lucky. I hate to say it, I just was lucky. I was in the right place. They recognized that I was very able in working with volcanic rocks, and I could actually progress the science. So in a sense, working with volcanic rocks for me was more or less handed to me. I'm not sure how to cut your way into it, if you like, other than get a degree, specialize in, and do a PhD in volcanic rocks, and look for opportunities either as a lecturer or through, if you have a National Antarctic Operator. In UK, you would have to work for someone like the British Antarctic Survey to get to work on volcanic rocks in the Antarctic. It may be the same elsewhere, I'm not sure. Most systems are, you have a job at a university, you write a proposal to work in Antarctica, and that proposal will be about volcanic rocks, and if you're funded, you go and work on them. But you have to have the experience beforehand. So you have to have not only a degree, but a PhD which is relevant to it.
So really quickly, our last question, there was two questions that was going in the same sense. How important are volcano and volcanic rock for life around Antarctica? Is there a study that study the impact of larvae in the habitat, the marine habitat, or anything else? Do we have any proof that the volcano impact life around Antarctica?
Okay, I unfortunately missed Pete Convey's talk earlier, but my suspicion is he will have touched on this because I worked with Pete on this very subject, and he is the expert far more than I am. I have simply given him, and also a colleague of ours, Crid Fraser in Australia, she's also expert in this, on the impact of volcanoes in helping terrestrial life in Antarctica to survive through multiple glacial cycles. From Pete's work in particular, he's been able to show that a lot of the life that lives on the land in Antarctica, and that's mites and midges and tiny little insects basically, they've been there for millions of years. They're endemic to Antarctica. They have not come into Antarctica and reseeded. They've been there a long time. They don't occur anywhere else. And yet there have been multiple glacial cycles. And with every glacial cycle, the ground should be scraped clean and this life should disappear. And therefore, what we should see in Antarctica today are far, far fewer species, a much lower level of species richness than we do see. And the answer, we believe, this is Craig Fraser's idea, working with Pete and myself, is that the volcanoes are acting as what we call refugia. And as a glaciation gets started and the ice is moving and grinding the rock surface and killing all life in Antarctica, the volcanoes provide heated ground. Oops, you gone? You still there?
I'm switching for the next person. Yes, I am here. I'm just switching while you're finishing to the next presenter.
Okay, no worries. Sorry, Louise. I'll finish. Yeah, they're providing hot ground, if you like, and these are steam fields which are able to create caves under the ice, and these little pieces of life, these little insects, are able to survive in these and survive quite happily until the ice begins to melt again, and then you get areas of snow-free and ice-free ground, and the wind can move them around and they can start recolonizing. So with every glaciation, the ice is not able to wipe out the life. And so if Antarctica didn't have its volcanoes, then I think life in Antarctica would be much less abundant than it is just now. So we believe volcanoes are the kind of missing link which we've been wondering about, how life has managed to survive for so long in Antarctica. They are actually very important for life.
Thank you very much, John. That was like an amazing topic. It's not something we hear often, and I think it was really highlighting a lot of people, certainly